I'm Svetok, so I'm a data engineer with Google, and I'll be talking a little bit about Beam YAML today. So yes, talking about a new SDK for authoring data pipelines called Beam YAML. So let's talk about what Beam YAML is. And so if you are familiar with Apache Beam as a way to author data pipelines, you may be familiar that we have 3 SDKs that are supported. So one of them is Java, one of them is Python, and one of them is Golang. But the thing is, these are all fairly verbose, and they require basically good expertise in the programming language, as well as some additional things that need to sort of be used in those ecosystems to run a pipeline. So I'll give you an example. If you're writing a Java pipeline in Beam, you're going to need a pom.xml file. And so similarly, these 3 SDKs come with their fair share of challenges. And so that's why we actually decided to introduce Beam YAML, which is sort of a much a simpler low-code solution to actually author your data pipelines. So what is YAML, right? So officially, the letters actually stand for yet another markup language. And so you can think of these as sort of config files, where you're defining configs and essentially setting properties, just like you would if you've used something like Kubernetes in the past. You can sort of set these files in a very declarative sort of format, and it's a lot less verbose. So the key here is that you're not going to need to know the specific semantics of a programming language, especially for more simple pipelines to write a YAML config. You can simply just sort of basically write your configs out and chain the transforms. And I'll show you multiple examples of that as we move forward. So as I was mentioning, this is kind of what it looks like. So you may have a pipeline, that a definition, and then you can define your transforms. And you can see here we have things like read from CSV or write to JSON. These are all native transformations in Beam YAML. And you can define, what's known as configs. And so that's essentially your parameters that you're passing in. So for example, a path you may pass in would be your path to your input CSV or your path to your output JSON. And you can specify what inputs certain transforms take. So this is a very elementary example of what it might look like to define a pipeline. So I'll actually flip over to my Cloud Console and show you another pipeline being run in practice. Cool. So my console here should be visible. And so if I actually open my editor here, you can see I have some files. And so I want to actually hone in on this beam batch SQL.yaml. So you can see here, I have, similar to what I'd shown on the slide, a pipeline definition, the type, which is chaining. So I'm going to chain some transforms together. And you can see here, I have a read from BigQuery transform, where I'm actually going to read from a specific table. And so this is just like you would use in your normal read from BigQuery. You might have your basically your data set name and your table name. And you can see that I'm writing a SQL query. So this would be, sorry, project. The first parameter here is project name dot dataset name, and then finally my table name. And you can see here next I have a SQL transform where I'm essentially querying the data set. So I'm going to select everything from it and just write it to JSON. So now, if I actually go into my Cloud shell, I can actually show you how or what command I would use to launch it. So I would use essentially what's known as a gcloud command, and you may be familiar if you're familiar with Google Cloud to some degree, but gcloud is a way to interface with some of the APIs in Google via the CLI. And so you can essentially specify a gcloud dataflow YAML run command. And so this YAML run command is very specific for YAML pipelines. And what would go after that is my job name. So I'm going to call this my Beam POC YAML job. I'm just going to specify the region that I want to spin up this job in. And I'll specify in this YAML pipeline file parameter. And that parameter is just going to be where I'm defining my YAML, which looking here, this is called the beam batch SQL.yaml. So if I hit enter, we can see that a job has actually created now. So it's created, current start time. So this is sort of your standard response that you may get when you spin up a job as a template, for example, or any kind of data flow job via the CLI. And so we'll check back on this in a little bit, where this job is. But we can go back to our presentation. So, okay, so that's a fairly kind of elementary pipeline, right? Now, what if I want to actually specify a data pipeline that is a little more complicated? So maybe there's some dependency management, right? Maybe there's some files that I need to copy over into my workers, for example, that my job needs to have access to, right? Like how may we do this? So in our other SDKs, something that we have support for is essentially called containerization. And you can think containerization is essentially where you can specify certain dependencies or certain things that you want to add. And you can actually launch your data flow job with that so that each worker or VM that does processing has a copy of those extra dependencies. Uh, and it's the same story in Veeam YAML. We also support containerization, and we can still use the gcloud command to deploy. And so I'll show you a quick example of that. So if I go back here, so you can imagine that maybe I have a file that I want to copy over, right? So we'll call it keystore.jks. So maybe there's just some content in here, right? We don't have anything right now, but we just say we have some content in here that we need to copy over so that our workers have access to this content. Well, basically what we can do here is we can create what's known as a Docker image. And you may be familiar with this if you're familiar with containerization or have used these concepts in the past. But all I'm going to do here is I'm going to take a base image called Apache Beam Java SDK, 2.3 version. So this is going to include all the dependencies that are included in that Beam SDK release. And then I'm just going to copy over this keystore.jks file. And I'm going to set an entry point to the script.sh. And so I'm not going to build the image because it's already built per se, but what I will show you is how I pull the image. So what's going to happen is that I have to build this image and push it to what's known as artifact registry that essentially has a bunch of my Docker images. And so when I want to use it, the first thing I would actually do is just pull it from there. And you can see here, we're just waiting for the pull. Great. So now my Docker image is pulled, and now I can inspect it. So you can see the previous command I ran was just a Docker pull on my repo. Next, I'm going to run this Docker run it, and then I'm going to specify the entry point. So now you can see I have my image. And if I just ls or list what's in it, I can see that, yes, my keystore.jks file is in this image. So that's good. So now I can exit. So now I'm all set to actually spin up a data flow job with this extra parameter. And so for that, I can actually, I'll just copy a command over. That is essentially going to be running this pipeline. And I'll show you which pipeline exactly we're going to run. But so I'm going to use a gcloud command, and you can see this command is a little bit different than the previous one. And why is that? We're actually going to launch this Beam YAML job as a flex template. And so if you're familiar with data flow templates, you may be familiar, we have classic templates and flex templates. So we're going to launch this actually as a flex template. And so you can see we're going to specify the job name. We'll call this test override 2. We need to specify a template file GCS location. So whenever you want to launch a Beam YAML job as a flex template, you need to pass in this parameter called template file GCS location. And so that GCS location is actually going to have a path to a GCS bucket. And so this this is actually going to be hard coded because what this is going to actually point you to is the latest Flex YAML template image. And so all this YAML template is doing is telling my my template launcher, hey, when you pass in a YAML file, I want this to be read as YAML. So that's how it knows, if you're launching this through a Flex template. If you use the gcloud dataflow YAML run command like I did previously, that's kind of already done under the hood for you, so you don't have to worry about it. But if you're running this as a Flex template, you need to specify that we have a YAML template Flex, basically that's going to tell us to read this as. Last time we'll specify a region, and we'll also specify some parameters here. And the main parameter we want to file is this SDK harness container image override. And this is just telling us that it's a Java image. And we are going to want to basically pass this Docker image here. And this is just telling us, okay, we want to use this Docker image in all of our YAML workers. And similar to last time, we have this parameter, so YAML pipeline file. And we can look at what that file is. This is actually a different job, so it's going to be our beam YAML poc.yaml. So you can see, we have something like read from Kafka, and we're going to write to PubSub. And so you may be familiar if you've written a pipeline before that reads from Kafka. There's a lot of sort of consumer config things that we need to specify. And so you can see that these are all specified here. And so I can just hit run. And you can see I have another job that's created, similar to last time with the same start time. So that's a little bit about how you can use containerization in basically your Beam YAML pipelines. And this is something that you may want to do, usually what we see is that people have some more complex use cases. So things like where you would need to actually install certain dependencies on your worker VMs or things like that. And so this is a great way to go ahead and do that. And I'll flip back to my presentation. Cool. So the last thing I want to cover is what about sort of our more complicated pipelines, right? Like, I've shown you some basic sort of pipelines of, okay, you can read from BigQuery and you can run like a quick SQL query and write it somewhere. And that's great. But what if you're an enterprise, or what if you're someone that has a lot of complicated logic, right? Like sometimes, the benefit of having the Java SDK or the Python SDK, et cetera, is that you can actually write these complex, the complex logic, business logic that you need to in your do funds as your processing pipeline can execute. So how do we carry all of that over into Beam YAML? And so the answer is that you can actually do this. And so you can essentially specify these complicated do funds in Java, and you can package it up into a jar and actually call it in Beam YAML. And so the main benefit of this that I see is really two things. So one of them is kind of division of infrastructure and business logic. So you can have a team that manages sort of writing your YAML pipelines declaratively, and then you can have other folks that are kind of maybe writing these Java parts of it. And basically you don't have to have like a full team of Java developers or Python developers developing all of Dataflow. They can have you can have much fewer folks with Java expertise really focus on that, and you can have other folks focus on the infrastructure piece of it, which is creating the actual pipeline via YAML. Another thing that this is really useful for is reusability. And so, oftentimes you may see that two business units have to kind of perform maybe a similar task, and so that maybe they write a similar, Pardo function, and it's not quite the same, but it's similar. But in this case, you can write it once, you can put it in a GCS bucket, and then any pipeline can call this basically this do fund. And so you're also enabling reusability, you're saving on tech debt. Like there's a lot of organizational benefits also with this sort of model. um, and so I'll show you a little bit about what that looks like in my console. So if I go over here, you can see I have this pipeline.yaml file. I want to run a job. I'll call it a pipeline, and again we're going to chain something. Uh, we'll define some transforms. At first, we'll create two sample elements, so maybe John and Jane with some IDs, and then we want to write a two uppercase transform. So this is going to kind of convert everything to uppercase, and we're just going to log it out for testing. So you can see already something that's different with this YAML file is that I have this, from line 16 onwards, I have what's known as providers. And so here I'm actually specifying a Java jar, and I am going to pass in a path to that jar. And you can see here I have two transforms, two uppercase and identity with specific unique resource identifiers or earns to identify them. And so if we look in here, actually, you can see I actually have basically this Java file. And I'm going to look quickly in basically, I can see I already have an identifier where this sum earn is defined. And I actually have basically the actual do funds defined here, which you can see to actually convert something into uppercase. And, I have the whole process element, etc. So I have all of this code written in Java, and there's no way I can kind of convert this to YAML, right? And so all I'm going to need to do is actually compile this as a jar and pass that jar in. So you can imagine, something I would need to do here is basically just run like a Maven clean package kind of thing, and I should be able to basically use that jar. Oh, okay. So I need to actually go into that directory. I need to go into the root directory. So if I go here, yeah, I should just be able to kind of compile this and it'll package it. Yeah, so you can see I have this Xlang 1.0 snapshot and it's going to continue building. Cool. So it built. I have this 1.0 snapshot. If I open my editor, that's essentially what I'm passing in here. I'm passing in this 1.0 snapshot jar, which is great. And yeah, so I can essentially launch this pipeline just like I did with anything else. I can use that same gcloud dataflow YAML run. So I'll just go to my root directory and then I will run that command. I'll just find it really quickly. Yeah, so it's going to be called pipeline YAML and gcloud dataflow YAML run, and then my Beam YAML POC job one. And yeah, just like this, it's my pipeline YAML file. So all I need to run is this gcloud dataflow YAML run, and you can see when I hit enter, a new job has been created. So maybe let's go see what some of the jobs that we've been running are up to. Cool. So you can see that first job, Beam POC YAML job. This is my read from BigQuery. You can see that it's actively working and the steps all look good. If you remember, we had a read from BigQuery step and then we had a SQL query and then we're writing to JSON. You can see we have quite a number of elements that are running through. The metrics look good. So, we expect this to finish in maybe like 5-10 minutes, perhaps. So yeah, you can see that looks good. And yeah, if you remember, my job looked like this. So I essentially read from BigQuery, selected from my IP collection, and then wrote to JSON. So that's exactly what's going on here. Similarly, my next job, all I was doing was reading from Kafka, writing to PubSub. That seemed to launch just fine. It's a streaming job, as you remember. That was where we actually overrode our SDK harness. So we used a Docker file as well. And so if we scroll down here, you can see that we actually had this SDK harness container image override with my actual image. And so that's good. That's being now passed into the workers, which is great. And the YAML is represented here on the side. Because you remember we used a flex template to do this. So this is essentially, these will be added just to show, okay, how is the YAML actually being parsed. And then we have our last job, which probably won't finish in time, but if the template launcher finishes, we can see that we've actually successfully launched a job with the jar attached to it. And so that jar is actually going to provide the business logic that we are going to use. And yeah, I think that's mostly it. One step I didn't show you is that I uploaded this jar to a GCS bucket beforehand. So you need to pass in a GCS path to upload jars to. And this is good because other sort of business units, you can enable them to have access to that same GCS bucket and have them reuse some of the jars as well. So yeah, at a high level, that's it for the demos. So, kind of a recap and talk about maybe some future directions. Where can we go with this, right? So something that's been brought up in the community is sort of bringing up testing frameworks for these pipelines. So how can we efficiently test a YAML pipeline, right? That's one sort of open question that we're kind of thinking about in the open source community. The second thing is just really having more transforms supported natively. So right now we have a handful, right? We have read from Kafka, read from BigQuery, read from PubSub. We have a number of things that are just natively supported. But we need to add more support and make these sort of on parity with some of the IOs that we have. And so it's not a super involved process, but if you're very interested, feel free to kind of add a PR if you're interested in, reading from a source or writing to a sink natively. And finally, just things like performance benchmarking against SDKs. So, where does the YAML SDK perform in relation to the Java and the Python SDK, right? Like how similar are they? When would YAML maybe be a good choice for an organization to use just based on performance? So with that, thank you for your time. Please reach out. I'm on LinkedIn here.